numbers or digits, and how many different unique passwords can she create? And you can repeat digits. So that is a key fact here. So a digit, and when it says numbers, that doesn't mean like 100, 500, 20. That doesn't count as a digit. A digit is like a single number. What I mean by that is a number that just has one character in it per se. What I mean by that is when you turn 10, you've probably heard the phrase, "Oh, you're double digits now because you turned 10," because you have 1 and a 0 for your 2 digits. So total digits consist, you can either have 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. A 10 is not a single digit number because there's 2 digits, so 10 does not count. But if you count how many options there are for digits, there's 10 of them. Okay. So again, I always like to fill out my little hangman slots. So we're doing 3 digits, so that means it's going to be 3 slots. So if you count out how many options there are for that first digit, there's 10. Second and third. For that second digit, there's still 10 because that key phrase repeats are allowed. So there's 10. So you can pick 2 for your first digit, but then you can also pick 2 for your second digit. If you picked 2, because repeats are allowed, if you pick 2 for your first digit, that does not mean you can't pick 2 again. And then that means that there's also 10 for your third digit. So 10 times 10 times 10. So you can either write that as 10 times 10 times 10 or just 10 to the third. And 10 to the third is 1,000. So there's 1,000 different unique passwords you can create with those 3 digits. But now she finds out that she can include letters as well as digits in her password. And she's deciding that she wants her password to consist of 3 numbers, digits, then followed by 2 letters. So there's going to be 5 because 3 plus 2 is 5. I'm going to make my little hangman slots, 5 for each character in the password. So if we have a number, I'm going to put numbers here just so to help us. And then letters. So the numbers are digits we know, and again, we can repeat, remember. So there's 10 options for each number that we pick. And then if we get to letters, this is where it gets a little different. Remember, you got to think of how many letters are in the alphabet. There are 26 letters. So that means if she's picking a letter, she has 26 options. And again, if she's picking another letter after that, repeats are allowed. So if she's picked the letter J, she can pick the letter J again. So there's still 26 options. So when you write that all out, you do that counting principle, and then you have 10 to the third times 26 squared. It's a really large number. I don't think it's even going to calculate on your calculator, but I just want you to understand how to do this. So now we're going to be determining between combinations and permutations. So they're both ways of arranging things. They're both ways of counting things. But the difference is that in one of them, order matters, and in the other one, order does not. For example, in a combination, let's say you're picking members to be on a team. So let's say we have Jimmy and Kate. So let's say they're both on this soccer team. So team members. Let's say we have the first pick and the second pick here. Let's say Jimmy's picked first and Kate is picked second. The reason why it's getting at order does not matter is because if you were to pick Kate first and Jimmy second, that is no different than that first selection and the right above it because order does not matter. But over in the permutation example, if we were to be picking someone to be president and vice president, if they have different roles, let's say Jimmy was elected president and Kate was elected VP, that is very different. That's a different outcome. Order does matter, because if Kate was president and Jimmy was VP, that's a different outcome. So again, when you're doing these types of problems, when you're identifying if it's a permutation or combination, you're going to want to look for keywords. What I mean by that is that keywords and combinations be creating a group of something, like a committee, a grouping, or a team. They have the same roles. For instance, if they're both we need same, co-captains, that means they have the same role. Like if they're not, so I have to sneeze. Oh, nope, false alarm. But over in permutation, some keywords are if you're ranking things, like if someone's getting first, second, or third, or if you're arranging things in an order, or like a lineup. Remember, key thing is that the roles are different. Like here, we had different roles. We had a president, and we had a VP. Over here, in the combinations, their roles were not different. They were both on the same team. Now we're going to do some practice with identifying if it's permutation or combination. So if we're choosing 2 desserts on a menu of 10, you got to think, does order matter? It does not matter. It just says we're choosing 2 desserts. It doesn't have us ranking the desserts or having them put in any specific order. So that's just a combination. Oh, a number now here for this third one or second one here, right here, it says picking a team of 3 from a group of 8. Let's look for that keyword team here. That means they're going to have the same role. So that order does not matter. So it's a combination as well. Now for this next one, we're selecting the president, VP, and treasurer. We know that they have different roles. See these different, we have president, VP, and treasurer. Different roles, order matters, permutation. Now we're forming a kickball league with 5 of our friends. I think league, that's kind of on the same lines as being on the same team. So order doesn't matter. So that's a combination. Now we're awarding gold, silver, and bronze at the track meet. So different rankings. They're getting different things. So order matters. So permutation. Now we're arranging 5 books on a bookshelf in order. So if they're in a lineup, like if they're in a line, then that means order matters, and that's a permutation. I'm going to go on and do some more examples. This is from your review, by the way. So if you feel confident with this, you can skip these next couple ones. So if you're picking 3 candy bars from a total of 10 at a checkout aisle, is this going to be a permutation or combination? And then we're going to solve it. Okay, so does the order matter is the question. Well, if you're picking candy bars, it doesn't tell us that we're lining them up in any way or that we're arranging them in any way. It's just we're selecting them from a group. So this would be a combination because the order does not matter. My pen would cooperate. Whoop, my pen is not working right now. Anyways, that's a combination. And then you'd write it out. Remember when you have combination, that's C. So it's the NCR. Pardon my writing. I'm having to use my mouse now because my pen's not working right now. So our N is our total. We have 10 combination. And our R is we're selecting 3. So you're going to type this in on your calculator or into that format on Desmos. And then you're going to get 10, 3. That's going to get you to 120 different ways. I'll do another one. So the members of a chess team want to choose a team captain and someone to organize their equipment. It's going to identify if it's a combination or permutation and how many ways. Okay. Does the order matter? Like, do they have different roles or are they having the same role? Even though it says team, even though I said team is a key word for combinations, I want you to look deeper and notice that they have different roles. So we have like an equipment manager in a way, someone to organize the equipment, and then we have a team captain. Because they have different roles, this is a permutation. That means the order matters. So then you're going to type, then let's permutation. What's our n? Okay, so there's 7 people total right here. And we're selecting 2 people. So our r is 2. So 7p2. Type that in. That's 42. Again, you can use Desmos or your calculators. Again, make sure that you guys are confident and you guys have completed all your assignments before moving on to the quiz.